AppArmor as a service. It is used to restrict access to programs. It comes pre-installed on most Ubuntu packages. Specifically, 18.4.3 is what we're using in this course. It acts as a mandatory access control and a discretionary access control, which allows system administrators to decide what ports, what security, and how they want to control their servers. There are several commands that are basic but need to be known when it pertains to AppArmor, specifically status, log proof, and gen proof. Status has three specific modes: an enforcement mode, a complaint mode, and an unconfined mode. Complaint mode allows you to perform almost all tasks without restrictions, but it will log them in a specific file, which I have posted here, log entries form. That's where the status will be logged at. You also have unconfined mode, which allows the program to perform any task and not log it, which is very dangerous for a system administrator because you want to see what's going on in your network at all times. Enforcement mode enforces, basically they are access controls where like you can only use specific programs, which will be a user interface. You would set these rules so that users can only use very specific programs. Log proof is when you update a profile. It's useful for existing profiles and allow deny anyone to do specific things or have access to files that they probably shouldn't outside of their classification or their work group, specifically their work group. Gen proof is for creating profiles. You use it to monitor or create a profile or application the first time it runs. Some of the specific permissions that can be set inside of AppArmor include inherit, child, deny, abort, and finish. Inherit creates the rules that denote it with an IX within the profile, causes the executed binary to inherit permissions from the parent profile. Basically, when you create a folder inside of a subfolder, the parent folder would be the main folder, and once you drill down into the folder, whatever you copy and paste into there automatically inherits the permissions of the parent folder. So if the parent folder only has read access, the subfolder will only, which is the child folder, will only have read access for whatever users. You can always use deny. You can also deny access to folders. You can abort a permission, which will leave without saving, and you can finish with setting permissions, which will actually save the permissions and get it ready for use. System CTL status shows the actual status of AppArmor and shows if it's running. That is one of the primary command lines that you will need to check and see if AppArmor is actually on and running. If not, you go back and you install it, and then you check again with that same command, and it will show you which version you have and if AppArmor is running. Another security feature for AppArmor is that it includes security warnings, which range from 1 to 10, which will tell you, will let a system administrator know, okay, we keep getting these specific warnings. You can, within this range, if it says 6, you can make it so, hey, anytime I get a 6, I need to be notified, and there's implementations that need to be taken so that we can react to this before it causes a vulnerability in our system. As we're using AppArmor to secure our Linux servers, we're using IIS to secure our Windows servers. IIS stands for Internet Information Services, which is a package on Server 2019. Specifically, we're using HTTPS. HTTPS stands for Hypertext Transfer Protocol Service, which is a derivative of HTTP was without the security, which ran on port 80. With this new HTTPS, it allows users to comfortably get on the internet and search sites knowing that there is a protocol put in place to allow them to search securely on the internet. This has become very important, specifically with search engines like Google, who has decided to put sites regarding HTTPS at the top of their search engine. And over the course of the next 24 months, we'll only publish HTTPS sites or sites that have a certification that's proven their HTTPS. HTTPS has become a very important protocol in today's society, specifically sites using, because individuals are transmitting more personal information over the internet, which needs to be secure and has very, very major implications when somebody gets private information. One of the main sites where you use HTTPS would be banking or anything that you would fill out personal information, which can be anything from a email address or PII, from an email address to a phone number to a regular street address. Some of the ways that HTTPS is used, specifically on a IIS server, is a new protocol called HSTS, which is HTTP Strict Transport Security, which allows a website to declare itself a secure host and to inform browsers that it should be contacted through only HTTPS connections, which means that if you don't have an HTTPS connection, you will get an error. Usually once that error comes up, it says, hey, this site is not trusted. Continue at your own will. That's normally what happens. There's a lot of ways that HTTPS can be hardened, specifically on the IIS server. You can lock elements and attributes, which allows the user to feel more comfortable, allows the system administrator to feel more comfortable about what sites the users can and can't go to. One way that is controlled is through an ACL, which is called an Access Control List, which gives permissions associated with each object. Those objects or permissions are called ACEs, which are Access Control Entries, which associates the permission that is giving with a particular identity. An example with this would be setting an ACL for a file or directory on an NTFS system, NTFS file system. One of the most important features for hardening HTTPS is SSL. SSL stands for Socket Secure Layer. SSL are certificates that are giving that establish a encryption between a web server and a browser. These certificates are gathered through a known trusted source or trusted agent. The process goes as follows. The server, the company hosting the server goes and buys a certification from a third party, which the industry considers to be trustworthy. The user goes and also has a certification which is considered trustworthy, or a server, whomever is managing the server. When the user attempts to access the website, the two websites meet and say, hey, is this server SSL certification trusted? Is your SSL certification trusted? A handshake is then given, which says, hey, this person is trustworthy and he can search the site. The information that is given, we can establish an encryption between the two of us. There are several ways to do that. Binding is primarily one of the first ways to do it, and secondly is redirection. Redirection allows For a system administrator to say, hey, I want to make this server only HTTPS. So any traffic that goes outside of that, which would be HTTP, has to come back and redirect to an HTTPS server. Sources for these came specifically from Microsoft Documents. There's a very detailed publication with this link that shows how to set up an ISS server, specifically what steps, what you can and can't turn off, and gives you a general idea of how an IIS server works. As far as AppArmor, I got it from a medium.com, which is a reputable source that dove into a very, very specific detail of AppArmor.